Good afternoon. I got my own table. I'm the only one that has a table. So I asked a question this morning at the keynote, and everyone basically just kept quiet. Now, I'm used to this because I've been coming to Korea for a few years, and I know that you don't like to answer questions, especially when there's a translator in the middle, right? So I was also told that I was going too fast for the translators. So today I'll try and slow down. Although it's going to be, I hope they can translate code because I'm doing coding. Anyway, so I will ask that question once again. And it's very, very simple. How many of you know Kotlin? Okay, good. How many of you are writing Kotlin code? Okay, right. How many of you are developers? Okay, because there's a AI track and a business track. If you don't, yeah, okay, never mind. So, this is like, right. Anyway, so what I'm going to show you here is a little bit of a recap of the session that Andre did at I/O, but I've slightly changed the demos, I've slightly changed the code. We're going to see some things that are similar, some things that are different. And the idea is to show you a little bit more idiomatic Kotlin, okay? So I'm assuming that you know the basics a little bit of Kotlin. If you've never seen Kotlin in your life, let's say main print line. Now I know Kotlin. Okay, there you go. Now you know Kotlin. Okay, so we've got that out of the way. Let's focus on the important things. Right. So we'll start with properties, and this is a typical example of a property. And the idea here is that I'm going to show you some code that you should never write. Okay. People that are generally new to Kotlin, what they do is, well, one of the things that we say you can do is you can come to the code menu and click this little button over here that says convert Java file to Kotlin file, right? And that's good in that it converts the code from Java to Kotlin, but often it writes it writes Java in Kotlin, if that makes sense. So it's not always using idiomatic Kotlin. And it's a very good starting point, but when you're writing Kotlin, don't just keep it to what that conversion does, right? There's other things that you can do. And here is one example of this, right? So this is a top level property where I have a custom getter, and then I'm saying, you know, if the system info is not null, then what I want you to do is get the system information and assign it to a field, right? Now this field, as you know in Kotlin, or you may not know, in Kotlin you do not have the concept of a field. You only have properties. So if you want to have a field belonging to a class, this is top level, but this could be a property of a class as well. You just basically create a private field, okay? So what I'm doing here is saying if the system is not null, then calculate the value, store the value, and essentially cache it, right? The idea is that I essentially cache this property. So when I run this, what you're going to see is that it's going to just write inquiring once, and then it's going to print out the values, because on the second and the third, it's basically going to cache the values. Now this is already built in the box for Kotlin, right? One of the questions that were asked this morning is, how do I do what are the benefits of me using Kotlin? To do this in a Kotlin way, you would use the lazy property, right? Here, what I'm doing is using property delegation. So first of all, this delegation is saying that I'm going to delegate the functionality of this property outside of this class, outside of this file or wherever it is, and I'm going to delegate it to a function. Now, this function is the syntax for a higher order function in Kotlin. If we navigate to it, we see that this is a higher order function that takes a function that takes no parameters and returns the type t. So I'm saying I'm going to delegate this property to this function over here. And this function is the exact same function that we had before, except if we put it side by side, you can see that essentially what it's doing is getting rid of all of this logic for me. I don't have all of this private fields. I don't have to worry about initializing it. I don't have to check that it's not null, etc. It takes care of that for me, right? And it's basically just doing the actual code that I want. And this is a built-in function inside the standard library. But there's other types of delegates that are available as part of the standard library. So another pattern is this one over here. So here I have an observable. And what I'm saying is that when the old value is set, when a new value is set, essentially do some function, do some functionality. In this case, what I'm saying is that I'm going to print out a value. So again, I have a custom setter. I'm passing in the new. I'm setting the old value. Field, if you're not familiar, is the default built-in field where you can store values of a property. So before you saw that I used an external field, which was called system info. Here, each property has a corresponding backing field called field, right? The word is called field. So here I'm setting the new, and then I'm printing out the value, right? So every time this property changes, it's going to execute some functionality. Observable pattern, right? How do I do that in Kotlin? There is a delegate for that again. So I again use property delegation, and I say observable. I pass in the initial value that the property has, and then I pass in a function, a lambda. And this lambda has 3 parameters: the property, the old, and the new. So the property here, are you familiar with this syntax in Kotlin? We'll see it a little bit later on, but it's basically using unused variables, and we'll see what that means. But again, if you do a side-by-side comparison, there is the logic. Everything else, I no longer have to implement. So I just write delegates observable, and then the actual functionality that I want, and I get the exact same behavior. If I run this, I'm going to get the exact same behavior as I got before. Another example of built-in support, vetoable. This is an interesting one, which is quite useful. Let's say that I want to set a property only if a certain condition is met. So in this case, I say, if the property value, if the value being set starts with a V, then set the property and also print out something on the screen. So again, you see that a lot of that is logic that I have to implement myself. If we look at the version in Kotlin, again, I'm using delegates.vetoable. Before it was delegates.observable, now it's delegates.vetoable. And I pass in an initial value, and then similar to before, I pass in a lambda, which has the property, the old value, and the new value. In this case, I don't need the new value, so I underline that as well, and I basically set out the code that I want executed, and if the condition is met, right? So these are all built into the standard library. You don't need to implement this functionality yourself. And they come in very useful when you're doing Android development or any kind of development like that. Okay? So I'm going to ask you a quick question, and I just want to hands up or hands down. Is the pace of the translation following the code? Are you following me? One person is, everyone else is not. Okay, that's great. I was thinking, like, the good thing about translating is that if I tell a joke, I can also say, please laugh now, and that will get translated. And you'll always end up laughing, right? So, except you didn't, but doesn't matter. Anyway, so let's look at some other things in Kotlin. First of all, as you know, everything in Kotlin is essentially an expression. So anything essentially can be treated as an expression. One of the things that you can do with Kotlin is create functions that are single function expressions. So for instance, if I have a function fun sum x int y int, I could, of course, say that this returns an int and then do return x plus y. Now, any function that can be expressed as a single expression can be reduced to a much nicer format, which is like so. Okay? So any function can be reduced essentially to a single expression function. And also, given that most of us have 4K monitors, we no longer have the 80 character limit on columns, right? We can have 600 characters on a column, so therefore any function can become a single line. And that was a joke. Laugh now. So the same goes for many other things. And one of the things that you should be doing with Kotlin is treating conditionals as expressions. So here again is a typical pattern that you find when you're writing Java code, right? Which is, I have a parameter, and then I set some variable, right? And then I say, if the parameter is some condition is met, set the value of that variable. Here I have a problem. The problem is that I'm using var. Var sucks. Generally, it's not nice because it's mutable, right? And we want to stay away from mutable values. So what I could do is I could lift this. And what I'm basically doing is I'm treating this conditional as an expression that returns the value. And how that works in Kotlin is that the last line of each branch is the value that's going to be returned. So I could come here and write print line, it's okay. I can has codes, right? And that's fine. As long as there's a value returned, then it's absolutely fine. And in this, I don't even need to return the same type. I can return a string. As soon as I return a string, though, however, that's going to give me an error if value is a defined type. If I do not make it a defined type and now make it mutable, that works, but it's saying that the conditional branch is moving from type int to type any, because one branch is returning a string, another branch is returning any, a number. So here you can see that now I've moved away from var to val, okay? You have the exact same pattern when you're doing a conditional, switch statement or a when in Kotlin. Again, you can use this as an expression. So one other thing with when statements or when expressions in Kotlin is that they're not bound to a single type of check. So I can say, for instance, when a value is 1, when a value is one of multiple, when it's a specific type, when it's in a range of values, or I can have an else branch, right? And this is checking on the actual single item, right? So it's checking on the value. But do you know that you can actually write when statements in a different way also in Kotlin? I can actually have completely different checks, right? So instead of putting the when and the actual condition at the top, I can put it in each branch. And then I can even check against different conditions, when sometimes that actually makes sense. Okay? Talking about expressions, the same goes for exceptions. Exceptions can also be treated as expressions. So here I'm saying return x plus y, else return a minus 1. Okay? Now, you can see even the ID is helping me. It says lift this return value. So now what I'm doing is I'm returning the value, and in case I cannot return a specific value, then it will throw the exception for me. Okay? So try and move towards this. And in fact, this can, in principle, even be expressed as a single expression function, right? I get rid of the return, I get rid of all of that boilerplate code that is not necessary, let the compiler essentially infer the types for me and cut down the amount of code I have to write. And much the similar way, we can do it with Elvis operators, right? So let's say, for example, here I have a check, if name is not null, throw illegal argument exception. Right? Again, I can change this and use the Elvis operator to say either return the value or throw an exception. Okay? And once again, in this case, I mean, in this, you can do it with either a throw or a return. Each of these can be treated as expressions. So try and move towards this kind of code when you're using Kotlin, because a lot of this is actually, either syntax of the language itself or as part of the standard library. And talking about the standard library, I mean, we've seen some functions, but let's take a look at a few other ones. So here is an example of a when statement similar to what we just saw, or in this case, an expression. And I'm saying, you know, update progress, when the value is less than 0, return 0. When the value is greater than 0, return 100. So I can write this progress 2 in a much nicer way. I could write something like this. Return value coerce in 0 to 100, right? And in this case, let's assume that this is going to return an int, a bool, right? So this coerce in is part of the standard library that essentially does these kinds of checks for you, right? You don't need to write all of this boilerplate code. Much the same way, let's take a look at a comparison, for instance. Here I have a sort person. So sorted with is part of the standard library. If you look at the standard library, it says, oh, it takes a comparator where it's going to do different checks against different values. So what do I intuitively do? I say, okay, well, it's going to take a comparator. Let me create an instance of a comparator. What is the comparator? That is basically a single expression, a SAM, and then I basically, you know, write the function that's going to essentially do that comparison. Again, this can be done in a much nicer way by doing something like sorted persons 1, and I do list of person. Then here we do persons sorted with, and now I say compare by, right? And here I can say person, age, person, name, right? Much cleaner, much faster, much more faster as well, because I typed actual less. So much faster, much cleaner, and more concise, and more to the point. I don't have to sit here and decipher all of this code to figure out what it's doing for me. And this essentially boils down to what? When people talk about functional programming, what we're doing is essentially using higher order functions, which are functions that take functions or return functions, and abstracting that away and using more abstract functions. And in this case, I'm using a function that's called compare by, which does all of this for me under the cover. And I don't have to worry about managing all of these temporary states and variables. Okay? Much the same way, maps. So here, for instance, this is also something that you could potentially do. I have a list of type entries that can be of nullable. First of all, this is, a word of caution. This is demo. Generally, if you are writing Kotlin code, stay away from null, right? If the only reason really you should be using nulls in Kotlin is if you're interoping with Java, right? And even when you're interoping with Java, make sure that the actual value that you're getting is nullable. And if it is not nullable, then just don't declare it as null. Okay? Don't write Kotlin code with question marks everywhere. There is a reason by default we say types are not nullable, not so that you can put question marks extra. If you miss typing extra characters, know that you can always put a semicolon in Kotlin. It's optional, right? By the way, does anybody know why we made the semicolons optional in Kotlin? So that you can have arguments about it on Hacker News of whether you should or shouldn't use semicolons. Laugh now. No, that didn't go well. Anyway, that was a joke. So here, I said that once, and they're like, really? And they pinged us, and they said, is this true? No. Nothing that I say on stage is ever true. Well, the numbers I said today were true. Anyway, so here I have a map, and then I'm checking, of course, if the filter not null. Guess what? There's already a function inside the standard library that does these checks. Now, you'll say, how do I know this? Very easy. You just take the standard library, print it out, and study it. But jokes aside, you can see that we're actually introducing this functionality inside the IDE as well, right? I mean, if I hover on this, it says, why are you doing this? Just use map not null, and it does the conversion for me. Okay? Now, coming back to functions, one of the things that we have in Kotlin are lambdas, of course, right? So I can say a higher order and that's a function. By the way, let me show you something very, very nice. That's the mathematical symbol for function, right? Now watch this. Are you ready? Ooh. It's like someone's like, okay, that's it. Now I am using Kotlin. Like, this is what's converted me to Kotlin. This and font ligatures. So, you laugh. One time I did a webinar for 1 hour on Kotlin, right? And I had one of the greatest guys that I love the most in terms of programming, which is Eric Meyer. And he's the moderator. And nobody is asking any questions. Nothing. 50 minutes in, Eric says to me, Hadi, there's a question. I'm like, yes, finally. And I said, what is it? Like, this is about Kotlin. And he says, someone's asking how you get this nice arrows in IntelliJ, right? Which is font ligatures. If you go to font ligatures, enable font ligatures, you see? Now you get the nice arrow. There you go. It's like 1 hour I'm talking about Kotlin, and this is what you want to know? I always say when I grow up, I want to be a programmer. Okay, so this is a higher order function. Now, if I type in something here, for instance, you know, higher order, and then I pass in a lambda. So in this case, let's say that the lambda takes an integer, right? And I say it plus 1. As you know that it, when a lambda takes a single parameter, you can reference it as it. So what happens here is that there's going to be a call, and that call is going to call another function, right? Now, this happens as part of many functions that are higher order because there's going to be a call to another call to another call, and you end up with a pretty big call stack. In order to optimize that in Kotlin, what we provide is a modifier that's called inline. And if you look at a lot of the functions in the standard library, so if I say, for example, numbers 1 to 100, and then do numbers filter those that are less than 5, you can see that filter has this modifier inline. And what does inline mean? Inline is a fancy way of saying copy-paste. So when I put inline in front of a function, what it's going to do is going to copy and paste that function inside of the call. So no longer there's going to be one call after another. It's basically going to copy and paste that function. Now, you usually only inline functions that are higher order functions. In fact, if I were to create a function, for example, multiply, that takes an int and a y, and that returns x times y, and I do inline of this, you can see that the IDE is going to give me a warning saying, you know, there is no significant performance impact of you inlining this. It really only makes sense to inline functions that have lambdas. In this case, it's absolutely fine. I can inline function, and it has a lambda, so it will actually inline the call and the actual code of the lambda. And this is a performance improvement. Now, this one, as you said, as we saw, it just said, no, you shouldn't do this. This isn't good. I mean, it doesn't give you many performance benefits. However, there are certain cases, and one in particular, where inlining can be used even if you do not want a performance improvement. And that is for reification. So you're familiar with the JVM, and the JVM has many wonderful things, and then it's got something that's not so great, which is called type erasure. So when you have type erasure, you often end up with a situation like this. I want to make a function that's called load service, and I need to pass in the class, the type. So how do I do that? I say a class of t, and then I do load, and then pass in the class, right? And this sucks, because I have to pass in this parameter when I'm actually having the type. Why do I have to do this? Like, if this is a generic function, why can't I just obtain the type from it? And this is where Kotlin can help you. You can actually make a function inline and add the reified parameter to it. And then what you can do is just then do Java class. Okay? So now I can actually get that type information. So reification provides me with some type of type information at runtime. It's not as exhaustive as, for example, C# and the CLR, but it does provide you with certain benefits. So if you're writing code that you need to pass types around, use inline functions with reification. Now, one other thing that's quite useful in Kotlin is that if I write, for instance, let's say I write get value, and then we'll have a string that comes in, and or let's even do an easier function. We'll call it myDivide, okay? Int y int, and I'll say this returns an int. So I say if y is not 0, then return x divided by y, else throw exception invalid, right? Now, I could just throw an arithmetic expression or whatever, exception, but here I'm checking to see if it's not divisible by 0, I'm going to return an exception. Okay? Now let me take this code away, and let's focus on this over here, right? Let's get rid of that. And I look at that function, and I say to you, is that function telling you the truth, or is it fake? If you only look at that function header, is that true or false? Now, you know what division is. So you look at that and you say, well, if I divide by 0, that's not going to return an integer, so therefore this is lying. But what if I call this Paco, right? Paco is a name in Spanish, or Joe, or Mary. You don't know anything about this. You're like, well, this function's returned as an integer, so it should always return an integer. But it doesn't. It's lying to you. This is what's called a partial function, because for certain input values, it is not returning an output value. So one way, which also moves into functional programming, is to try and make functions total and say that it returns a specific type. So instead of returning an int, I can say that, for instance, this returns a value, right? A division value, for instance. So I can say this returns a division value, right, a class. And now this class could actually be of two types. It can have a division valid, which inherits from division value. Right, this needs to be open because, as you know, classes, and division invalid, which is also inheriting from division valid, division value. Okay, and we're going to see this is going to be the result of type integer, and this is going to be a message of type string. Now, I say this is division value, right? Division value. Division. What did I write? There you go. So now I'll say this is division valid, and it's going to be x divided by y, and this is going to be division invalid, division invalid, can't divide by 0. Now this is true. This is a total function, because for any input value, it will always provide a result. Okay, let's assume there is no arithmetic overflow, just for the sake of argument. Okay, so stop harassing me. So here, this pattern is what's called an algebraic data type, right? Which is a function that returns either one value or another value, one type or another type. The problem here is that now comes a friend and says, you know what? I'm going to come here and I'm going to create a class division sometimes value when sun shines, right? And this is going to inherit from division value. Okay? So that works. The problem is that you don't know about it. So how, because the class is open, anyone can inherit from it. But I don't want that. I just want to be able to express my algebraic data type, which is saying it's one type or another. That's where the sealed keyword comes in Kotlin, which is essentially providing you with the ability to close the hierarchy. So this is no longer valid, right? So the sealed keyword limits you to anything that is in that specific file. This can be nested classes or non-nested classes, but it limits you to everything that can be in that file. And this pattern is actually, as I said, is quite useful, and it's used quite a bit with people that do functional programming. And you don't need to do this boilerplate code all the time. In fact, there's libraries. One of them, for instance, is called Arrow, that allows you to, has this type built in, which is called either, and then you can return either a value or either one value or another type of value, another type. Okay. And then when I use this, again, I can say, well, let's say that, when, let's introduce a val result equals my divide 1, 10, and then here we'll say when result is division value, then print line result, and you can see that I actually get result dot is division value. My divide is division valid, sorry. Is division valid. So I get result dot result. So it actually does the auto smart casting, right, that Kotlin has. And if I do is division invalid, then I get print line result dot message. Okay? Now, if I add another one here, let's call it just D for the sake of argument, division value, this doesn't give me any issues. However, if I were to treat this as an expression, now it says that this is no longer exhaustive. Now it says that you need to either have an else branch or cover the pending type. That is another reason why you should move towards expressions in when statements in this case, right? So here, if I get rid of this D, everything is fine. Otherwise, I would have to add another branch. And this is good because this is a problem we often have. We introduce a new enum, and then we're like, oh, let me search and replace all the places that I've got an enum and add the other branch case, right? So try and move towards expressions all the time. So to finish off, let me show you a couple of things with another more built-in functions. So here I have, for instance, a class configuration. I can say config, configuration, and then I pass in some values, and then you do config dot credentials, config dot credentials, config dot host equals something, credentials equals credential, and config dot port equals 9090, right? And you just write the same thing over and over and over and over again. You're constantly writing this config, 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 config. Now what you can do is use, again, built-in functions. And if you ever remember, anyone ever used or know of a programming language called Delphi or Delphi? Yes, the good old days. It was awesome. Not that now it's not awesome, but you know what I'm saying. So that had a construct with, which basically allowed you to set properties of a record. So I could do with config, and then here, essentially take this stuff over there, put it up there, and then I can get rid of the config, right? And now I've got access directly to that. An alternative to this is I do another config1, and then I do configuration, apply, and then do similar in the apply block, right? So take that and apply the values in the block, right? Again, these are two functions that are built into the standard library, okay? So let's take this just a little bit step further, because what I could do is instead of doing it like this, what I would love to do is something like this. Let's get rid of this one over here. I'm going to say I want a config over here, and then I want to have a configuration over here, right? And then I want to set the credentials, and in the credentials I want to do something like that, right? So let's get rid of this one over here, and we'll say username equals me, and password equals password 1234. That's not my password, by the way. I always put an ampersand. Okay, so this starts to look nice. It kind of looks like JSON, and it's nice in that I've gotten rid of this with. I don't have this continuous constructs that are being used. But how do I do that? That's where you get into the aspects of the DSL. And what you can do essentially is this. If you look at this pattern, what this is a function, right? This is like a function, and here's the Lambda block. So I could create a function called configuration, right? Now, what does configuration take? It takes a Lambda, so it takes a higher order function, right? However, if we look at this higher order function, what is it? Well, it's this higher order function that has access to some properties of this class called configuration. Now, this class configuration, how could I potentially do that? Well, Kotlin has this thing called extension functions. You're familiar with it, right? You can take a type and extend it. Essentially, everything in the standard library is an extension function. Extension function is a function. If it's a function, can I take an extension function and pass it as a higher order function? Absolutely. So what I can do is say I'll pass in a configuration, right? And this configuration is now my extension function. So you can see that this now has magically disappeared. This host and port now works, right? Because this Lambda is an extension function to configuration, which means that the Lambda has access to the properties of that class. And then we can repeat the same procedure here, right? In this case, I'm saying credentials. So now I could do this in multiple ways, but let's say that, for instance, what is credentials here? Credentials is an instance, right? So this is an instance of a type credential. And what I'm trying to do is I'm trying to call it as a function. Now, can I do that in Kotlin? Yes, you can. If you have a class called A, what you can do is you can say val A and then call A. How can I call A? You create an operator called invoke, right? So now I can call A. So if I can do that, let me do the same thing here. Create an operator called invoke, and the parameter has to be what? It has to be credential extension, much like before. And now you see that voila, I've got my nice DSL, okay? And that, my friends, is what we call domain-specific, language-driven development, where you start with what you want and then you basically alt-enter your way to get it. You don't even need to know Kotlin. You just alt-enter all the time, okay? Thank you very much.